Okay, then good morning, everyone. I think video is clear, no? Video is clear, and sound also clear, no? Blur करके तीनों बात करें. Good morning, good morning. Wait a minute. Okay. Today we are going to start mechanics today, mechanics lesson. As we discussed earlier, today we are going to discuss mechanics. Okay. Actually, this is the most important lesson in physics. And I am here. So this is the most important lesson in the physics today. In physics syllabus. Actually, in MCQ question, in MCQ paper, actually there will be 12 to 13 MCQ question. 12 to 13 MCQ question in mechanics. Okay. Then structured paper. The structured paper, then definitely there is a one question. Definitely there is a one question from the first experiments. And then in the essay question, in the essay paper, definitely there is a one question in mechanics. Therefore, look at that one. So actually, if you can understand mechanics and if you can do the questions in mechanics very well, that means definitely you can go for a very, very good mark today. And that is a must. අනිවාර්යෙන් දෙයක්. Mechanics පුළුවන් නම් අනිවාර්යෙන් physics හොඳටම පුළුවන් වෙනවා. හරිද? Mechanics ඊළඟට electricity වලදී. Okay. So this is the single unit. This is the single unit that actually this unit contributes very, very big portion in our paper. Therefore, this unit is the most important unit among the 11 units of syllabus. Okay, okay, syllabus එකේ තියෙන unit 11 ගත්තොත් ඒ unit 11 unit වලින් ගත්තොත් වැඩිපුරම වැඩිලා unit එක තමයි දෙන්නේ. හරි. Okay. Mechanics. Actually, we can classify mechanics into 4 categories today. According to your syllabus, we can simply categorize mechanics into 4 main categories. What are those? Static, dynamic, angular motion, and fluid. Okay, actually, angular motion can be categorized as dynamic, but it is sometimes actually there are some different characteristic of angular motion. Therefore, I have categorized that part separately. Okay, so basically we can classify mechanics into 4 main categories. What are those? Static, dynamic, angular motion, and fluid. Angular motion and fluid. Okay, fluid can be further categorized into 2 categories: fluid static, fluid dynamic. Okay. Okay. Actually, static means it is a study of stationary objects. Static means it is a study of stationary objects. So Static means the study of stationary objects, and dynamics means it is a study of moving objects. And this is a study of stationary object. So this is a study of moving object. That is angular motions. Angular motion means it is a non-linear. Those are non-linear motions with it. So under this dynamic category, we will learn about linear motions. Linear motions means motion in a straight line. Angular motion means those are some non-linear motions. Non-linear motions. So it is a study about non-linear motions. Non-linear motions. And so it is a the study about non-linear motions. Non-linear motions. Fluids. Fluids mean you know about fluids. So in fluid study, we will learn about stationary fluids. In fluid dynamics, we will learn about flowable fluids. Flowable fluids. Okay. So this is a study about stationary fluids. This is a study about flowable or moving fluids. Okay. Shall we write? You have to take a new book. You have to take a new book. සාමාන්‍ය මේ ෆිසික්ස් වල පොත් ගනිද්දි මේ සිංගල් රූල් පොත් ගන්න එක හොඳයි. ඔය නිකන් අර මේ පොට් රූල් ගන්නවට වඩා. හරි. මොකද සිංගල් රූල් ලියන එක ලේසි. හරි. ඒ කියන්නේ බැච් පාර්ට් එක තිබ්බා වුණාට ඒ පොට් රූල් ගන්න එපා එකක්. මේක මේ හරි අමාරුයි. ඒක පැහැදිලිත් නැහැ. මේ يعني අපිට කොහොමද එක්සෑම් එක ලියන්න වෙන්නේ පුතේ සිංගල් රූල්. ඒ නිසා ඒ විදිහටම ලියන එක හොඳයි. හරි. Okay. Then write a topic mechanics. Don't write anything. Write the main topic mechanics. It is unit number 2. Unit number 2 mechanics. This is the main topic. Unit number 2 mechanics. Write the main topic. Unit number 2 mechanics. Then write on that. Mechanics can be classified. Into four main categories. According to the structure of yellow paper, according to the structure of A-level paper, the following number of questions, can be given in mechanics lessons. MCQ 12 to 13 questions. Structured essay. That means 12 marks. 12 to 13 marks. 12 to 13 marks in the final paper. Okay? Structured essay, maximum one question. Structured essay question means that is 4 marks. 4 marks. 4 marks in the final paper. The essay. Essay one question means 7.5 marks. Okay. 7.5 marks. (7.5 marks in the final paper. Okay? Final paper 7.5 marks in a essay question. Again, all together. අපි මේක මිනිමම් ගත්තොත් 12යි කියලා 16යි 23.5 වගේ වගේ 280 283.5 marks in the final paper. කියලා final paper එක ගත්තොත් එහෙම පුතේ ඒකේ questions වලින් මේ කියන්නේ අපිට අත්‍තරම මේ at least 25% වගේ මෙතන හම්බ වෙනවා. Now පුතේ this is the beginning. This is the beginning. This is the beginning පුතේ. This is the beginning. Our first topic, main topic is unit 2 mechanics. Under that topic, we have written this one. Mechanics lesson can be categorized in 4 main categories according to the A-level. According to the structure of A-level paper, the following number of questions can be given in mechanics lesson. The following number of questions can be given in mechanics lesson. Then you have write this one. Don't write this one. You have write just this one. MCQ question 12 to 13 questions. That means 12 to 13 marks in the final paper. In the final paper, the structure is say one question. That means 4 marks. 4 marks in the final paper. Not 4, 5, sorry, 5 marks. 5 marks. This strategy 5 marks. This second is 5 marks. But 24.5. So if we consider about mechanics lesson, actually almost 25% of the final mark, where all 25, almost 25% of the final marks can be taken from mechanics lesson. බලන්න. එක lesson එකක් තිබ්බත් ඇති බලන්න 25% හම්බ වෙනවා. හරි. ඒ කියන්නේ තව මොකක් කරකට දාගත්තා නම් පාස් වෙන්න පුළුවන්. හරි. අන්න ඒක තියෙන මේක වටිනාකම. හරි. Okay. Shall I erase this one? Shall I erase?
Okay, sir.
Thank you, Madhu. Right under that. The mechanics lesson can be divided into the following categories. The mechanics lesson can be divided into the following categories. Now you can draw this chart, mechanics. It can be divided into 4 categories: static, dynamic, angular motion, and fluid. Static, dynamic, angular motion, and fluid. Static means a study of a stationary objects. Dynamics means study of moving objects. Angular motion means a study about nonlinear motions. Fluid. It can be further divided into 2 categories: fluid static and fluid dynamics. Fluid static means it is a study about fluid study. Fluid study this is a study about flowing fluids. Fluid static means it is a study about stationary fluids. Stationary fluids. Okay, write down this thing. Once you complete writing, please let me know. Once you complete writing, please let me know. Thank you. Right. Okay, you can write under fluid study. It is a study about stationary fluids. Study about stationary fluid. A study of stationary. Okay. Now we are going to start static lessons. Static lessons. Okay. Now write another main topic is statics. Static. static. Okay, under the static, we are going to start vectorism. Okay, vector. Actually, in your syllabus, we have to teach some part of vector lesson in unity dimensions lesson unit dimensions unit. But the thing is, I think it is not needed because you have to learn about vectors again in unit number 2. Actually, it is about mechanics. Okay. Therefore, I'm going to learn all the things as a one single unit. Okay. Therefore, we are going to learn about all the things about vectors in this lesson. Okay. So under the static, the first main topic, it is another main topic, is vector. Now we are going to start vectors. Vectors. ඇත්තටම අපි මේ සිලබස් එක ගත්තාම පොඩි පිස්සු කෙලිය තියෙනවා. අපි කියන්නේ ඇත්තටම දැන් අපි එකක් මේක අනික වැඩිපුරම මේ ඔය විදිහටම පිස්සු විදිහට සිලබස් එක දීලා තියෙන ඊළඟ ලෙසන් එක තමයි පුතේ හීට්. හරි. හීට් ලෙසන් එක මුලින්ම පටන් ගන්නව තර්මෝමීටර්ස්. අපි තර්මෝමීටර්ස් ඉගෙන ගන්න කලින් ළමෙක්ට කියා දෙන්න නැහැ. මොකද්ද ටෙම්පරේචර් එක කියන්නේ මොකද්ද හීට් එක කියන්නේ මොකද්ද මේ දෙකේ වෙනස මොකද්ද ඊළඟට දැන් අපි තර්මෝමීටර්ස් වල සෙන්සිටිවිටි එක ගැන කතා කරනකොට ඇකියුරසි ගැන කතා කරනකොට අපිට මොකද්ද අපි කතා කරන්න ඕනි හීට් කන්ඩක්ෂන් එක ගැන හීට් ඇබ්සෝප්ෂන් ගැන ඒවා අපි කතා කරන්නේ ඒව එකක්වත් කියා දෙන්නේ නැතුව මුලින්ම දාලා තියෙන මේ තර්මෝමීටර්ස් දැන් තර්මෝමීටර්ස් ගැන ළමෙක්ට මුල ඉඳලා ඒ විදිහටම කියා දෙන්න කිව්වොත් එහෙම මේවල මොකද තේරෙන්නේ නැහැ. ඊට පස්සේ නම් මේක කරන්නේ අනිවාර්යෙන් කටපාඩම් කරගන්න. ඊට පස්සේ කටපාඩම් කරලා අයි අර යුනිට් එක ගන්නට ලොජිකලි අරේන්ජ් කරලා නැහැ. යුනිට් එකක් ලොජිකලි අරේන්ජ් කරගත්තේ නැතුනොත් එimma අපිට කටපාඩම් කරන්න හරින ඕන දෙයක් නෑ කරන්නේ. ඔන්න ඕක තමයි ෆිසික්ස් වල තියෙන ගොඩක් ලොකු ප්‍රශ්නයක්. හරිද? අයි යුනිට් එකක් ලොජිකලි අරේන්ජ් කරලා නැහැ. ඔය එන එක්කිනා අරේ චුට්ටක් දානවා මෙහෙන් චුට්ටක් දානවා අර මොකාගේ අරාණියක් දෙනාගේ කැදහැලිය වගේ තමයි පුතේ ඒක අර ලංකාවේ තියෙන සිස්ටම් එක තමයි මේ මොකද්ද අර එක එක්කෙනා එක එක ඒවට පස්සේ ඉතින් මේ කිසිම ලොජිකලි අරේන්ජ්මන්ට් එකක් නැහැ මේ දැන් ලොජිකලි අරේන්ජ්මන්ට් එකක් නැතුණාට පස්සේ ෆිසික්ස් වගේ සිලබස් එක වෙන්නේ ළමයට තේරුම් ගන්නම ඒක තමයි ඇත්තටම මේ ගොඩක් වෙලාවට මේ අර ද ෆේල් පර්සන්ටේජ් එකේ වැඩි වෙන්න හේතුවත් මේ එකක් ඔක බලපානවා මොකද මේ ටීචර්ස්ලා උගන්වනකොට සිලබස් එක දිහා බලාගෙන උගන්වන්න ගත්තොත් එහෙම මට තේරෙන්නේ නැහැ සමහර වෙලාවට. හරිද? තේරුණා වගේ ඊට පස්සේ අපිට හිතට ඔය වෙලාවට ක්වෙස්චන්ස් ගන්න ගත්තට පස්සේ ආයෙ තේරෙන්නේ නැහැ. හරිද? මේ දැන් මේක සාමාන්‍ය තාම මුල් පාන නිසා ලොකු අවුලක් නැහැ. නමුත් විශේෂයෙන් ඔය හීට් වගේ ලෙසන් එකකට ගත්තොත් එහෙම හීට් ගොඩාක් ළමයිට ඔය හීට් ලෙසන් එක අමාරු වෙන්න හේතුව ඔන්න එක තමයි. හරිද? මේ හීට් ලෙසන් එක තනි කරම අජපල් කරලා තියෙන්නේ මේක නම් ලොකු අවුලක් නෑ මොකද මේක අර ඩිමෙන්ෂන් ඉන්ටර්ඩිමෙන්ෂන්ස් වල තිබ්බට පස්සේ ඊළඟ සාසර අපි ඒත් එක්ක මැකනික්ස් පටන් ගන්නවානේ ඒක නිසා මේ අපි නිකන් කටින් කියන විතරයි තියෙන්නේ කොහොමත් කන්ටිනියස්ලි කරගෙන යන්න තියෙන්නේ පුතේ හරි අය ඉන්ටර්ඩිමෙන්ෂන්ස් වල අන්තිම කැලේනේ එතකොට අන්තිම කැලේ නිසා කොහොමත් අපිට මේ කරගෙන යන්න බෑ තියෙන නිසා මේක ලොකු ප්‍රශ්නයක් නෑ නමුත් හීට් වලට කියන පස්සේ ලොකු ප්‍රශ්නයක් හරි ඒක නිසා මම හිට් කරන්න වෙන ඔය විදියට කියන්නේ මම හිට් කරන්න ගන්නට ලොජිකල් ඇරේන්ජ් කරපු විදියට එහෙම නතුව කරන්න බෑ. නැත්නම් ළමයට කියා දෙන්න බෑ තේරෙන්නේ නැහැ. හරි. හොඳයි. Okay. Now we are going to start the discussion about vectors. Now tell me, I know you have done this part in your all syllabus. Okay. Now tell me What is a vector? What is a vector? Can you tell me? What is a vector?
Any physical quantity that has a magnitude and a direction.
Yeah. Vector is very good. Very good. Vector is a physical quantity having both magnitude and direction. So that is the definition. Sometimes you may hear about the definition of vector with line of action and point of actions. And somehow that is very wrong. Wrong definition. Okay. Definition and definition. If you consider about vectors, there are three type of vectors. And I will learn that thing. I will teach that thing. Okay, I will teach that thing. But before that, you have to have this idea. In vectors, according to the definition of vector, vector means it is a physical quantity that having a magnitude as well as a direction. Okay. So according to the features of vectors, vectors can be further classified into three main categories. Okay. One, those categories are free vectors, then sliding vectors, and tight vectors. Actually, those are categorized under those three categories because according to the presence of line of action and point of action. I think you may hear that those two words, line of action and point of action. Line of action and point of action. Okay. Some vectors may have all the vectors should have a magnitude and a direction. So those are the two features. Those are the two features common for all the vectors. But some vectors have line of action. Instead, line of action further to these two features. Okay. Further these two features, some vectors can have line of actions. Something like force with it. And we will learn that thing. Force. If we consider about force has a magnitude, a direction, as well as a line of action. And some vectors may have in magnitude, direction, line of action, as well as a point of action. Some vectors have a specific point of action. As an example, weight. Normally, weight is exerted from the center of gravity. This point is called as center of gravity. Therefore, the weight has a specific point of action. So this point is called as the point of action. The point of action, now it has a line of action as well as a magnitude and direction. Therefore, line of action and point of actions are two features of vectors. But the thing is, those two features are not common for all the vectors. They are not common for all the vectors. And those are the two common features for all the vectors. Therefore, if you want to define vectors, you have to use the common features for all the vectors. And therefore, you cannot use these two characteristics to define vectors. මම කිව්වේ සමහර වෙලාවට line of action point of action ඕගලන්ට ඇහෙන්න පුළුවන් vectors define කරනකොට line of action එකයි point of action එකයි කියලා කියන්නේ පුතේ හැම vector එකටම common feature එකක් නෙවෙයි. හරිද? දැන් අපි as an example if we take about velocity. Velocity is a vector quantity, no? Velocity is a vector quantity. Is there any line of action or point of action in velocity? Point of action? Can we say about the line of action and point of action of velocity? No, we cannot say. If you can say about velocity, displacement, those kind of vectors do not have line of action and point of actions. They do have magnitude and direction only. And therefore, according to the presence of line of action and point of action, we can classify vectors into three categories. What are those? Free vectors, sliding vectors, and time vectors. We will learn this in future today. I'm not going to explain this within this class, but I have to mention that thing because sometimes you may hear the definition of vectors using line of action and point of action, but that is wrong. That is wrong because line of action and point of actions are not common features for all the vectors. Did you get my point? Perhaps they lead. Therefore, what is the definition of vector? So, vector is a physical quantity that having magnitude as well as a direction, because those are the two common features for any kind of vector. Any kind of vector. Then the main topic, vector, then the subtopic, the definition. The subtopic is the definition. Already subtopic, for subtopic, it's definition. Okay, write another definition. A vector is a physical quantity. A vector is a physical quantity having a magnitude as well as a direction. Having a magnitude as well as a direction. Okay. Tell me some examples for vectors for this. Vector quantity. Tell me some examples. Oh, yeah, examples.
Force,
Yes. You can write example. Force. Again, the one?
velocity, momentum,
Velocity. Yes, velocity. It is a vector. Another one? Yes, displacement. Displacement. What else?
speed,
No, speed is not a vector quantity. It is a scalar quantity. It is a scalar quantity. It doesn't have a direction. It has a magnitude only with the speed. Speed and distance, those are some scalar quantities. Work is not a vector quantity. Work is not a vector quantity.
momentum,
Momentum is a vector quantity. Weight, yes, weight, that is correct. Weight is a vector quantity. Power is not a vector. Yes, moment of a force, that is a vector quantity. Moment of force. Moment of force is a vector quantity. Acceleration is a vector quantity. Yes, acceleration also a vector quantity. And sorry,
Pressure.
pressure is not a vector quantity. Okay. Then write that one. Write down this thing. Examples. Okay. Definition. Then write a second topic, second subtopic. Scalars and vectors. Scalars and vectors. Right. We can write some example for scalars and vectors because normally you will be asked this kind of questions. This is very common questions in A-level paper because especially about work, power, pressure, because those kind of things can be confused. And sometimes students can confuse with work, pressure, power. Okay, those are not vector quantities. Those are not vector quantities. Those are scalar quantity. I will describe that thing when we doing those subtopics. Okay. මම කරනකොට කියලා දෙන්නයි කොහොමද නැත්තේ කියලා දැනට තේරුම් ගන්න. ඒවා ස්කේලර් quantity, ඒවා vector quantity නෙවෙයි. හරි. Vectors. Scalars. So scalar means scalar means those are the physical quantity that having a magnitude only. Magnitude only. And okay, vectors. Force, acceleration, velocity, displacement, the work, scalar work, power, speed, the distance, speed, distance, power, what else? Pressure, moment of force, the momentum, mass. Mass is a vector scalar quantity, but weight is a vector. Weight is a vector. Weight is a vector, but mass is a scalar quantity. Time is a scalar quantity. Time. Write down this thing. Yeah, energy is a scalar quantity. Work and energy. Work, energy. Work, energy. Scalar quantity. Impulse is a vector, Pute. Impulse is a vector. Impulse is a vector. If you want to write that one, write down. Impulse is a vector. Impulse. What is? Okay. අපි මේ එක එක මේ හැම මේ ස්කේල් හැම ෆිසිකල් ක්වොන්ටිටි එකක් අපි වෙන වෙනම කතා කරනවා. Okay. Strain is a scalar. It is a scalar. Strain is a scalar. It doesn't have a direction. It doesn't have a direction. We are going to discuss each and every physical quantity mentioned in this table today. We will discuss that thing. So when we are discussing those physical quantities, then I will describe why they are categorized under these two categories. Okay. Until then, you have to remember those things, because if you are given this kind of question in your test paper, you have to give the answer with it. Therefore, you have to remember that thing until we are going to until we learn about that thing.
Sir, stress comes under which, sir?
The stress is a scalable. The stress and strain. Stress and strain.
Torque.
Sorry?
Torque.
Torque is about moment of force. Those are some same. The torque is vector. Torque is a vector. Torque is a vector. Torque is a vector. Then stress is a scale. Once you complete writing, please let me know. Okay. They write a third subtopic. Differences between scalar quantities and vector quantities. Differences between scalar quantities and vector quantities. Okay. Can anyone tell me what are the differences between scalar and vectors? What are the differences?
Vector quantity has magnitude and direction, but scalar quantity has only magnitude.
Yes. That is one. First one. Okay, write down the thing. A vector has a direction. A vector has a direction but a scalar quantity doesn't have a direction. Another difference. Another difference. Yes, very good, very good, very good. That is a main, very, very important differences between two quantities. Actually, for scalar, for scalar, we can do normal mathematical operation. Scalar means just numbers, no? Just number. Scalar means they are just numbers. Okay. Then we can add, divide, multiply in our normal way. But for vectors, we cannot do the mathematical operation in such ways. Okay. As an example, suppose now there is a man here. Okay. Now he walks into the east direction about 40 kilometers from the point A. Then he turns into the north direction and he travels 30 meters, 30 kilometers, 30 kilometers, and comes to the point B. Now come to the point B. Now tell me, what is the total distance he traveled? What is the total distance he traveled?
70 kilometers.
Sorry, 70 kilometers. Yes, it's 70 kilometers. We can just add these two numbers. No, it is very simple. We can add those two numbers because it is a distance. It is a distance. This distance means it is a scalar quantity. Scalar quantity means it has only a number. Therefore, we can add those numbers in normal way. But suppose if you are asked to find the displacement, how to find the displacement? Displacement is what the displacement
A to B short distance.
Yes, A to B. A to B is the displacement. A to B. So this is the displacement. Okay, this is the displacement. This is the displacement. Okay. So you cannot find the displacement by adding those two distance. You cannot find that part. Okay? To find the displacement, you have to do some another mathematical operation such as Pythagoras theorem or another geometrical mathematical operation. And so in this way, in this case, we can use Pythagoras theorem to find A to B distance. To find A to B distance. So using Pythagoras theorem, we can prove the displacement from A to B is equal to 50 kilometers. But the thing is, we cannot perform mathematical operations for vectors in normal way. Okay? But we can do for scalars. Did you get my point?
Yes, sir.
Yes.
Okay, then write down the second difference. Okay, second difference. Normal mathematical operations can be performed for scalar quantities. But but that cannot be applied, that cannot be applied for vectors, but that cannot be applied for vectors, that cannot be applied for vectors. Okay, we can write this example for it. We can write this example. The total distance travel is equal to 40 kilometer plus 30 kilometer. And but the displacement is equal AB length. So we have to apply Pythagoras theorem to find displacement. Okay, then write the fourth topic. Representation of a vector. 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 Fourth topic, representation of a vector. Representation of a vector. Proton representation of a vector. Now we have to identify, we have to represent a vector. Okay, representation of a vector can be done in two ways. First thing is geometrically. We can geometrically represent a vector. Geometrically. Geometrically. The second way is algebraically. Algebraically. Geometrically and algebraically, we can represent a vector. Geometrically means it is a representation of a vector using a figure. Geometrical means it is about figures. And therefore, we have to represent a vector using a figure. So if we represent a vector using a figure, that is called a geometrical representation. And so if we represent a vector using some notations such as some English letters, then that kind of representation is called algebraic representation. Algebraic representation. And, so geometrical representation is representing vector using a figure. And so this is algebraic representation means it is a representation of vector using English letters. Because when we are doing mathematical operation, such as some algebraic operation, we cannot use geometrical representation. We cannot use figures to put it. Therefore, we have to represent a vector using some notation. So in such cases, we need some algebraic representation. So we have to have both representation method to represent a vector. Okay. But in the you have to identify this thing. A vector. A vector means it is a physical quantity that having both magnitude and a direction. Vector has a magnitude as well as a direction. So when you are representing a vector, you have to represent both magnitude and the direction. So that is a mandatory thing. So when you are representing a vector, you have to represent its magnitude as well as the direction. Okay, shall we look into this? Okay. The topic is representation of vector. They write on that. A vector is a physical quantity. That having a magnitude as well as a direction. Therefore, both magnitude and direction, both magnitude and direction should be represented during the representation of vectors. During the representation of vectors. Write in a new para. This can be done in two ways. This can be done in two ways. First thing is geometrical representation. Geometrical representation. The second thing is algebraic. Algebraic representation. Geometric representation means using figures. Algebraic representation means using letters. Using letters. Okay. Then I had a subtopic, geometrical representation. I had a subtopic, geometrical representation. Geometrical representation. Geometrical representation. Geometrical representation. Okay. But a vector means it has some specific direction with it. It has some specific direction. Suppose to the north or to the east, to the north. Likewise, it has some specific direction. So as the vector has a specific direction, we can represent a vector using a straight line. Using a straight line with arrowhead. Using a straight line with an arrowhead. Because suppose the vector is directed to in this direction, then I can represent the vector using a straight line or line segment which is drawn into the direction of vector. Into the direction of vector, and we can use an arrowhead to represent the actual direction of the vector. Therefore, you have to draw a line segment into the direction of vector, and you have to mark the direction of the vector using an arrowhead. Okay. So then you can represent the direction of vector. Now, one thing is so look. Now, direction can be represented by this one. So, how to represent the magnitude? Then, how to represent the magnitude? Can anyone tell me?
Using numbers or letters?
Sorry?
Using numbers?
No. Actually, in this case, we have to define the length. We have to define the length of line segment according to the magnitude of vector. Suppose we need to represent 50 Newton force into this direction. If we need to represent a 50 Newton force into this direction, first I can define we can say 5 Newton will be represented by 1 centimeter. 5 Newton will be represented by 1 centimeter. If so, 50 Newton should be represented by 10 centimeter long line segment. 10 centimeter long line segment. So, if I define the scale, then I can draw a line segment which is equal to the magnitude of that vector. Therefore, the magnitude of that vector can be represented by the length of this line segment. By the length of this line segment. So we can adjust the length according to the definition of the scale. We can adjust the scale. Okay. According to our requirement, we can adjust the scale. The most important thing is the magnitude can be represented using the length of the line segment. Length of the line segment. Did you get my point? Then when we represent a vector using a geometrical way, we can use a line segment which is drawn into the direction of the vector. Then we can represent the direction of vector by the arrowhead, using an arrowhead. Okay. So that is a method of representing the direction. Then the magnitude can be represented by the length of this line segment. The length can be defined. According to the scale that is used in this case. Did you get my point?
Yes, sir.
Therefore, we can represent this one, 15 Newton. And this line segment is equal 10 centimeter long line segment. So when you represent a vector in geometrical way, so you have to mark these 2 points. These 2 points in capital letters. Okay, this point is called as the starting point. This point is called as the starting point. Starting point of this vector. Because the arrowhead is directed. Because the arrowhead, this arrowhead is directed towards the B. Towards the B means this vector starts from A and directed towards the B. Therefore, the point A is called the starting point, the point B called the end point. Or termination point. Therefore, you can use the arrowhead. To determine the starting point and the end point. Okay. So arrowhead is directed towards the end point. And arrowhead is directed towards the end point, from starting point to end point. Arrowhead is directed from starting point to end point. Therefore, using that notation, you can identify what is the starting point, what is the end point. Alien. Everyone, I need your responses.
Yes, sir.
මොකද දැන් ඉස්සරහ මම කියවන්න ඕන වචන වලින් කියවන්නේ. Only 2, 3. Only 3. What about others? හරි. So this is the way of representing a vector in geometrical way. And then how to represent a vector in algebraic method? So in algebraic method, normally we use English letters to represent a vector. And, oh, we can take this vector. So this vector can be represented in algebraic way as AB vector. AB vector. Look at this one. In algebraic method, we can start from the starting point, then the end point. Starting point and the end point. Then you have to use an arrowhead. Arrow to mention the direction. And so in this method, both magnitude and the direction are presented. How to do that? From the arrowhead, it is very clear the direction of this vector. The direction of this vector is from A to B. And the magnitude of this vector is equal to AB line segment. AB length. And therefore, magnitude of this vector is equal to AB length, and direction is from A to B. So when we are using a algebraic representation, this one should be the starting point. This one should be the end point. Okay. So this is a one way. Of representing vector in algebraic method. Okay. There are several ways to represent algebraic method. We can use simple letters such as simple A, simple B, simple C. Those are some another method of representing vectors in algebraic method. So in this case, those are just notations. Those are just notations. Like those are just notations. And make algebraic method in detail තියෙනවා. මේ විදිහට represent කරොත් in detail තියෙනවා. මේ වගේ ගත්තොත් එහෙම අපිට in detail නැහැ. හැබැයි they are just notations. They are just algebraic notations. We can use this one. We can use capital letters also. So if we use this kind of notations, there are no any starting point or end point. Those are just notations. Suppose x comma when we are doing algebraic calculations, we can use x, y as variable with it. So likewise, we can use simple A, simple B, simple C, A, B, C when we are doing calculations of vectors. මේක අපි ලේසියට ගන්න. මේක අපි අතරම in detail ලියන විදිය මේ තියෙන්නේ in detail ලියන විදිය. හරි. මේක අපි අර ලේසියට ගන්න විදිය. හරිද? මේ දෙකම algebraic representations තමයි. හරි. Okay. මේක වෙනම ලියන්න. Then the topic is geometrical representation. No, okay. Under the geometric representation, you can draw this figure. Just draw this figure. Don't write this one. Make auto correct. Just draw this figure. Okay, everyone. Then write under this figure. Write under this figure. A line segment. A line segment. A line segment. A line segment with a magnitude and a direction. A line segment with a magnitude and a direction. A line segment with a magnitude and a direction. To a scale parallel to a vector. 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 Is known as a geometric vector. A geometric vector is known as a geometric vector. Is known as a geometric vector. The magnitude, write in another para, write in another para. The magnitude of the vector, the magnitude of the vector the magnitude of the vector is denoted by is denoted by the length of the line segment. The length of the line segment. The direction of the vector, the direction of the vector, the direction of the vector direction of the vector is represented by the direction of the line segment, the direction of the line segment, the direction of the line segment, and the arrowhead on it, the arrowhead on it, the arrowhead on it. right under the right in the new para. The arrowhead, the arrowhead, the arrowhead is always directed, is always directed, is always directed to the end point of the vector, to the end point of the vector. Then the next topic, subtopic, algebraic representation of a vector. Algebraic representation of a vector. Algebraic representation of a vector. Write down on that. Write down on that. Okay. A vector quantity, a vector quantity a vector quantity can be represented, a vector quantity can be represented a vector quantity can be represented algebraically, algebraically algebraically using algebraically using symbols, using symbols such as follows, using symbols such as follows, such as follows. Okay, now you can write down this. What examples with the Hello. Then write a sixth topic. Magnitude of a vector. Sixth topic is magnitude of a vector. Okay. Now we call it as modulus. Magnitude. The another name for magnitude is modulus. Modulus of a vector. Hello. Okay. The topic is magnitude of vector. Right? Hello. In mathematics, magnitude of any quantity can be represented by this symbol. This symbol. This symbol is called the modulus symbol. Modulus symbol. Okay, modulus symbol. Okay. So any magnitude can be represented by this symbol. Suppose you are given this kind of expression. Suppose you are given this kind of expression. AB vector and what is the meaning of this symbol? The meaning of this symbol is you have to take the magnitude of AB vector. Magnitude of AB vector. Therefore, the meaning of this symbol is equal to the magnitude of AB vector. AB vector. Or in other words, we can use modulus. Modulus of AB vector. Okay. So the symbol is called as modulus symbol. Modulus symbol. That means suppose now there's a vector here. Now there's a vector here. Suppose the vector is 10 Newton. The vector is PQ. That means suppose if you are asked the magnitude or modulus of PQ. So what is the answer?
10 Newton, sir.
Yes, very good. That is equal to 10 Newton with a 10 Newton. So modulus of vector is the magnitude of that vector. So the symbol represents the modulus or the magnitude of a vector. Okay, we can add on this thing. Magnitude. Sorry, the magnitude within the brackets modulus, the magnitude within the brackets modulus, close the bracket of a vector can be represented by Please may I write this one. Can be represented by symbol. Symbol can be represented by, you have to write this one. Can be represented by symbol. Okay. Now the symbol is called a modular symbol. Okay. So the meaning of this notation, is equal to magnitude of AB vector or modulus of AB vector. Modulus of AB vector. Okay. Now you can go this way. Write this one, and the name of this symbol is modulus symbol. Then the meaning of this notation is equal to the magnitude of AB vector or the modulus of AB vector. Write this thing. All good thing. Then write the seventh topic. Some special vectors. Seventh topic. Some special vectors. Some special vectors. Okay. Take 7.1. 7 is some special vectors. Then 7.1 is null vector. The null vector. The symbol of null vector is this one. 0, this null vector. Okay, according to the name of this vector, you can understand. You can get an understanding about that part. Null vector means it is a zero vector. Zero vector means this vector doesn't have a magnitude. Magnitude is zero, and magnitude is zero. Okay. මොකක්ද මේ කුණහරුප කියලා අහන්නේ magnitude එක 0 වෙනවා නම් මොකටද මේ value මේව දැන් තියෙන්නේ කියලා අහන්නේ. ඒකට පුතේ අතන අපිට මේක මේ මෙතන ලොකයක් අපිට ඕනි වෙන්නේ නැහැ. හැබැයි maths වලදී අපිට හරියටම ඕනි වෙනවා null vector කියන කතන්දරේ. Okay. There are the topic null vector. Null vector. හරියට දෙන්න පුතේ. හරි. අද උදේ මේ අපේ වයිෆ්ට වාහනේ උගන්න ඩ්‍රයිව් කරන්න පුරුදු කරා. පුරුදු කරලා මේ වාහනේ හොදන්න පොඩ්ඩක් ඉස්සර දාලා ආවේ. මාර ගැම්බර පිටිපස්සට අරගෙන මම සද්ද වෙනවා මම බය දිවි ඒකයි කියට වැන්නේ. ඔය හරි වටගත්තත් ඒ ෂේප් එක අරගෙන සද්ද හැලුණා මම දිවි ඒකයි ෂුවර් නෑ. හරි. මෙයාට උදේ ඊළඟට null vector. Okay, null vector. Okay. Null vector is a vector. Null vector is a vector whose magnitude is 0. Whose magnitude is 0. Okay. Therefore, magnitude of a null vector is 0. We can represent it as using the modular symbol. Using modular symbol. Okay? Using modular symbol. Null vector. The magnitude of null vector is equal to 0. Okay. Find the mistake. Okay. Once you write down this thing, the second topic, second is 7.2 topic is the unit vector. The unit vector. The symbol is U. Okay. According to the name of this vector, you can identify the feature of this vector. Okay, unit vector is the vector whose magnitude is equal to 1. Whose magnitude is equal to 1. Okay. Write down that thing. The unit vector is the vector whose magnitude is equal to 1. Whose magnitude is equal to 1. So it can be represented by this.
Done, sir.
Unit vector. Then third one, 7.3. The negative vector, 7.3 is the negative vector. Negative vector. Within the brackets, reverse vector. Negative vector or reverse vector. (7.3) negative vector or reverse vector. What do they make you? Can anyone imagine?
What, sir?
Can anyone imagine what will be the negative vector or
The
reverse?
negative symbol will be there. Minus.
Actually, suppose you are given a vector from A to B. Suppose this vector is simply. So negative vector means it is the vector that having the same magnitude, but the direction is opposite to the direction of the considered vector. Okay. Like you know. Like you know. Like you know. Okay, so negative vector means the magnitude is equal to the magnitude of the given vector, but direction is opposite. Direction is opposite to this one. So this one is negative A, negative B. Suppose this one is 3. Negative A. Have anything? Have. C to D, no? C to D, C D vector. Make a AB vector, make CD vector. Have. So when you are calling a vector, you have to call from here to here, from starting point to end point. Have. Make a DCM again. CD vector. CD vector, this one AB vector. AB vector. You have to start from the starting point and the end point, terminate from the end point. When you are calling a vector, you have to start from the starting point. DC vector. This is not DC vector, this is CD vector. CD vector. Okay. This one is AB vector. That is the way of pronouncing a vector. Okay. So negative vector is the vector whose magnitude is equal to the given vector, but the direction is opposite to the given vector. Magnitudes are equal, but directions are opposite. Therefore, directions are opposite means AB should be equal to CD. Should be equal to CD. Okay. As they are in the same direction, but only the thing is the arrowhead is opposite to the arrowhead of AB. Therefore, AB and CD are two parallel lines today. They are two parallel lines. They are two parallel lines, but the arrowhead is in opposite direction. Is in opposite direction. So that is the negative vector of a given vector. So negative vector means it is a vector whose magnitude is equal to the given vector and direction is opposite direction to the given vector. Okay. Okay. Therefore, if you want to determine the negative vector, definitely magnitude should be equal to each other. Two line segments should be parallel to each other, and arrowhead should be in opposite direction. Arrowheads should be in opposite directions. Okay, those are the features of a negative vector. Those are the features of a negative vector. Negative vector. Negative vector. Write down the T. Write down this. Write down on the topic. The negative vector. The negative vector. The negative vector of a given vector. The negative vector of a given vector is the vector whose magnitude is equal to the given vector and the direction and the direction is in opposite way. Is in opposite way. Okay, then you can write down those things. So those are the features of negative vector. If it is a negative vector, both line segments should have same dimension, and those line segments should be parallel to each other. But the only difference is the arrowhead. Arrowhead should be in opposite direction. Anladım.
Yes.
Okay. They write the 8 subtopic, 8 point. Equality of two vectors. Equality of two vectors. Equality of two vectors. Equality of two vectors. और अभी equal vectors हम लोग का निकालेंगे तो हमारा मेथड अभी डिस्कस कर equality of two vectors. Equality of two vectors. And now tell me. Now there are two vectors A, B, and C, D. A, B, and C, D. B and C, D. So if they are equal to each other, then what will be the requirement to be fulfilled? If they are equal to each other, then what are the requirements to be fulfilled? Can anyone guess? Can anyone guess for it? Suppose you are given two vectors A, B, and C, D.
Direction.
I didn't hear you, though.
Magnitude and direction. And also the
Sorry, the magnitude and direction. Magnitude and direction.
And the both vectors should be represent the same.
Very good. Yes, Putu. Very good, very good. So in this way, actually both magnitude and directions should be equal to each other. That is obvious because a vector is a physical quantity that represents a magnitude as well as a direction. Therefore, both magnitude and direction should be equal to each other. On the other hand, both vectors should be represent the same physical quantity, Suppose to this direction, there's 10 Newton force and 10 meter displacement. Okay. So in this case, both are in same direction. Therefore, directions are equal to each other. And magnitude also equal to each other. Magnitude is 10. But the thing is, this is a force, this is a displacement. Therefore, these two forces cannot be equal to each other. We call this as the homogeneity. Okay. Therefore, both vectors should be equal in magnitude, equal in directions, and the homogeneity should be maintained. Homogeneity should be maintained. That means both vectors should represent the same physical quantity. I've done that thing. To have equal vectors, to have equal vectors, the following requirements have to be fulfilled. Number one, magnitude should be equal. Number two, direction should be equal. Number three, homogeneity. That means homogeneity means both vectors should represent the same physical quantity. Both vectors should represent the same physical quantity. Okay. Suppose there are two vectors AB and CD. AB and CD. Suppose this one is A vector, this one is B vector. So if A vector is equal to B vector, if A vector is equal to B vector, then what will happen? Definitely, AB length should be equal to CD length. This is the length, only length. AB length should be equal to CD length. AB length should be equal to CD. AB length should be equal to CD. Magnitude are equal. Then definitely AB line segment should be parallel to CD line segment. Those two line segments should be parallel to each other because directions are equal. Therefore, they are directed into the same direction. Therefore, they should be parallel to each other. Therefore, AB parallel to CD. Then the third one, the direction of arrowhead. The direction of arrowhead should be equal. The direction of arrowhead should be equal. Direction of arrowheads should be same. Should be same. So if you are given two vectors, if they are equal to each other, those features to be fulfilled. And okay, now please look into the vectitude. Vectitude. I have shared the vectitude with you in our group. Okay. Then quickly do the question number 1, 2, and 3. 1, 2, and 3. First one, there is a parallelogram, AB, CD parallelogram. There are 8 vectors in the direction of AB, CD, sorry, AB, CB, DC, AD, AO, CO, and OD, and OB. List the equal vectors and reverse vectors of the following figure. Suppose all the vectors represent the same physical quantity. Takara, you can learn it. To take vector 2, vector tip number 1. Your question number 1, 2, and 3. Takara. But I will take the one with the no. Okay, shall we discuss? In the first figure, there is a parallelogram. A comma B, C and D. There are two diagonals. So B R A S B Q C D. You have determined the negative vectors and equal vectors from these diagrams. Equal vectors. So what are equal vectors? Equal vectors. Tell me. What are equal?
BCN
Huh?
BC equals with AB.
BC vector?
No, sir. DC.
DC, DC is equal to AB. Yeah. You can use this symbol A and C. A and C. A equals C. Vector A equal vector C. Then vector A and C are equal. Then is there another? D equal B. So D. Man,
No, sir.
D and B are not equal. D is in this direction, B is in opposite direction. How? You know. There are only two. B equal D. B equal minus D. Right? D equal R. Oh. There are two different directions. D and B, R and D, there are two different directions. Magnitudes are different. Magnitude also different. And D is not equal to R. D is not equal to R. May they not equal may then a direction they have changed. If they are equal to each other, definitely they should be parallel to each other. And magnitude also equal to each other. Both the magnitude and the direction are not equal. Therefore, there are only two vectors which are equal to each other, A and C. Did you get my point?
Yes, sir.
You got it? Then negative vectors. Negative vectors. Bar negative vectors. And it's very clear. These two are negative vectors. Ne? D and B. D and B are negative vectors. Therefore, I can write this one. B is equal to minus B. Minus B. Negative vectors. D is equal to minus B. Then, as this is a diagonal, therefore this length and this length should be equal to each other. Ne? Yes. Therefore, we will look at this one. R and Q, both are same in magnitude and opposite in direction. Well, R and Q. R minus Q. Both are sub 2 different. Yes, R equal to minus Q. Yes. Then S and P, S and P, S and P, they are equal in magnitudes, opposite in direction, opposite in direction. Therefore, and both are parallel to each other. Both are parallel to each other. Right? With එකම line එකේ තියෙන එකම line එකේ නම් ඉතින් අනිවාර්යෙන් parallel. හරි. නිසා P is equal to minus S. මම මොකක්ද කිව්වේ? එකම line එකේ නම් parallel කියලා කිව්වේ. පුතේ. එනවා. What is the definition of two parallel lines? What is the definition of two parallel lines? Two parallel lines are, well, two parallel lines means they should be directed in the same direction. In the same direction. Therefore, if we consider about the same line segment, but two portions, both two portions are directed into same line, same direction. Therefore, these two portions are parallel to each other. But the only thing is, there is no gap between these two. Therefore, AO and OC. AO and OC are two parallel segments, but there's no gap. There's no any gap in between them. And did you get my point? Therefore, some portions in the same line can be considered as parallel lines. Clear? Then the next one. ABCD is a square පුතේ. Sorry. මම ඉඳගෙන කරන්න මේ දෙවෙනි එක. දෙවෙනි එක මම පොඩ්ඩක් කියන්න පුතේ කරන්න. ඒක මම දැන් කියා දෙන්න ඕනි. හරි. දෙවෙනි එක මම පොඩ්ඩක් කියා දෙන්න ඕනි. Third one. Sorry මට අමතක වුණා. Third one කරන්න පුළුවන්. Third one. මම මේක මැකුවා. මේක තේරුණාද දැන්
Yes, sir.
Thank you.
Yes, sir.
Okay, then the third one. There are two parallels. A, B, C, D, E, F. Then yeah, A, sorry, G, the A, the B, C, D, E, E, R, S, T, E, enter. Okay. දැන් බලමු equal vectors. So what are the equal vectors?
So FD, EC, and AC.
I can F
FD,
FD FD hari FD
EC,
equal E, then
EC,
E equals EC ECI equal EC E equals C
AC,
okay
ANC,
ANC yes ANC are both all are E C and A.
then we have R and P.
R and P R and P R and P both are equal R and P. Alright. Alright. Is there any additional? When there are
No, sir.
according to then opposite sorry negative
F and B,
F
and B,
and B yes
B.
F and B F and B F and B
S and
then,
Q,
sorry minus
S and Q,
S and Q yes S and Q S is equal to minus Q
G
then
and A,
G
G
and
and
A yes G and A G and A G and A G A
and
and
D
G
and B.
and E G and C nede
Yeah, sir.
is equal to minus E and as well as minus C.
So D and B, D and B,
D and B D and B ne D and B then D and minus B and D and B yes SQ GA FB yeah DB how are the answers today hurry hurry with it there are another topic now is I think 9 ne 9 no atak divara 9 tanne determining the magnitude of a vector using a non-vector using a non-vector ඔන්න බලන්න පුතේ මේක පොඩ්ඩක් හැමෝම හොඳට අහගන්න especially bio කට්ටිය okay especially bio students maths එකේ මේක ගොඩාක් වෙලාවට මේ වගේ දේවල් යෙදෙනවා ඒ නිසා maths එකේ මම ඉන්නේ maths එකේ ලියන නේ maths එකේ ගොඩාක් මේ දේවල් යෙදෙනවා ඒ නිසා ඒගොල්ලන්ට මේක අමුතුවෙන් කියන්න නැති දෙයක් වෙන්න පුළුවන් නමුත් bio කරන කට්ටිය ගොඩාක් හොඳට අහගන්න maths කරන කට්ටියත් ගොඩක් හොඳට අහගන්න මොකද තාම ඕගොල්ලන්ට කියලා තියෙන්න පුළුවන් හරි okay look at this one. Okay, now suppose there is a . 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 ABC rectangle triangle. Suppose you know the length of AC. The length of AC is x. The length of AC is x. And you know the angle theta. You know the angle theta. Okay. Now tell me, how to find the other two sides. How to find the other two sides. You know the value x and you know the value theta. You know the value theta. How to find AB and BC?
So using trigonometric sine theta and cos theta.
Yes, we can use trigonometric ratios. We can use trigonometric ratios with it. So if I use sine theta, sine theta is equal to BC over x, ne? Opposite side over x, BC over x. Therefore, BC is equal to x, x sine theta, opposite x sine theta, x sine theta. Therefore, if you know the hypotenuse and angle, if you know the hypotenuse and the angle, the opposite side to this angle is equal x sine theta. X sine theta. Right. Now, look at this one. AB. How to find AB? You can use cos theta definition. Cos theta definition. So definition of cos theta means that is equal to the adjacent side over the hypotenuse. Adjacent side over the hypotenuse. Therefore, adjacent side is equal x cos theta. X cos theta. Again, මෙයා මේ පැත්තට ගොනොත් ඒ කියන්නේ adjacent side එක පුතේ මොකද වෙන්නේ x cos theta එක. So if you know the hypotenuse and an angle, the adjacent side is equal to hypotenuse into cos theta, opposite side is equal to hypotenuse into sin theta. And try करूं. You know this one and you know this length. You know this length. Now you have to find AB and AC. How to find that one?
Sine theta equal AC over x over AC.
Yes, very good. Now I can use sine theta. Sine theta is equal opposite side, that is x over AC. Therefore, AC is equal x over sine theta. X over sine theta. X over sine theta. Therefore, this one is equal to x over sine theta. X over sine theta. Then how to find AB?
AB equal yes sir. Cos theta equal x over sine theta over AB.
Now we don't know x over sine theta. And
Sorry sir, cos theta equal AB over x over sine theta.
no. Suppose if we do not know AC. And
AC then sir, or hypotenuse.
now we have found the AC of the. So without finding AC, how to get the value of AB?
Cos theta equal AB over AC.
No, we don't. Suppose we do not know AC. Okay. I'm asking without finding AC, how to get the value of AB? Without finding AC? Yes, very good. Tan theta. We can use tan theta. Tan theta is equal x over AB. X over AB. Therefore, AB is equal x over tan theta. This is equal x over tan theta. Tagabon. Ini lagi apa lagi? Produk yang ukuran Google kan membeda kan? Theta. Suppose this one is 6 now. Now this one is 6. Now how to find BC and AC? BC and AC. BC. How to find BC? To find BC, I can use tan theta, right? To find BC, I can use tan theta because I know the adjacent side and angle. I want to find the opposite side. I'm willing to make it. I'm willing to what are the data you have? What are the data you have? So in this case, you have an angle, and you know the adjacent side. Angle, adjacent side. Then you want to find the opposite side. Right? You know angle, you know adjacent side. You want to find opposite side. Angle, adjacent side, and opposite side. So what would be the trigonometric function combining these three? It is tan theta. So that is the way of determining the relevant trigonometric functions. Okay. Theta, that is the angle, adjacent side and opposite side. Angle, adjacent side and the opposite side. Angle, adjacent side and the opposite side. So what will be the trigonometric function? It should be tan. It should be tan. Not a confused. So දැනගන්න අනිවාර්යෙන් ඔයා ගාව තියෙන data මොනවද? ඔයාලා තියෙන data එක මොකද්ද? එහෙනම් ඒ තුනම combine වෙන trigonometric ratio එක මොකක්ද? හරි. So in this case, angle, adjacent side and opposite side. Angle, adjacent side and opposite side. The relevant trigonometric function is tan. Therefore, if I write tan theta, it is equal to BC over x. Therefore, BC is equal x tan theta. BC is equal x tan theta. Then again, I need to find AC. So what would be the appropriate trigonometric ratio? Takal again.
Cos theta, sir.
Cos theta. How to find that one? Make angle, adjacent side, opposite side. Angle, adjacent side, opposite side. Angle, adjacent side, opposite side. Then what is the ratio? Cos theta. It is cos. Therefore, cos theta is equal x over AC. Therefore, AC is equal x over cos theta. X over cos theta. AC is equal x over cos theta. X over cos theta. Did you get my point?
Yes, sir.
Okay. Okay, now we are going to determine the magnitude of unknown vector using a non-vector. Therefore, in this case, we have to use some trigonometric relationships with it. Suppose, in this case, suppose you are given a vector into this direction, that vector is equal to 10 Newton, and you are asked to find a vector into AB direction. Then you can find that AB vector using a trigonometric ratio. And suppose you are given a vector in this direction, suppose it is 5 Newton, and you are asked to find a vector in BC direction. So it is very easy, you can use the trigonometric ratio. And therefore, that is the application of this method to it. And did you get my point?
Yes, sir.
Anita? හරි. හරිද අනිත් අය? Okay. අපි මෙහෙම දාගමු පුතේ. ඉතින් in this case, we need to use geometrical and we need to use some we need to use some geometrical and trigonometrical relationships to determine the length of to determine the magnitude of a vector, to determine the magnitude of an unknown vector determine the magnitude of an unknown vector using the magnitude of a given vector. Using the magnitude of a given vector. හොඳයි. මුද දැන් ඔය මේ මොනවාද වෙක්ටර් කරද්දී අනිවාර්යෙන් ප්‍රී රික්වයර්මන්ට් එකක් තියෙනවා. ඒ තමයි ජියොමෙට්‍රිකල් නොලෙජ් එක. ජියොමෙට්‍රිකල් නොලෙජ් එක ඕනේ. ඒක තිබ්බොත් මොනවාරම ලේසි වැඩි කරන්න. විශේෂයෙන් අපි ස්පෙෂලි අපි ගත්තොත් තියෙන පැරලගම්ස් ගැන. පැරලගම්ස් ගැන ඒ වගේ තියෙන ෆීචර්ස් ගැන අපි පැරලගම්ස් වර්ග කීපයක් ගන්නවානේ. රොම්බස්, ස්ක්වෙයාර්, ඊළඟට rectangle, rhombus, square, rectangle, and normal parallel. Those are the four things to think. And you should have the knowledge about their properties. What are the properties of rhombus? What are the properties of a square and a rectangle? Okay, you have to have that knowledge. And those are the basic knowledge. And ඒකත් එක්ක trigonometric knowledge එක තියෙන්න ඕනේ අනිවාර්යෙන්. මේ වැඩේ කරන්න. හරි. ඒ නිසා grade 11 පුතා අරගෙන පොඩ්ඩක් බලන්න especially parallels නේ. ඔක්කොම geometry ඕනේ නැහැ. geometry ඉච්චර ඕනේ නැහැ. හැබැයි parallels වල තියෙන geometry නම් අනිවාර්යෙන් මෙතනට use වෙනවා. හරි. නිසා parallels වල තියෙන special features මොනවද? ඒවා තියෙන relationships මොනවද? ඒවා අනිවාර්යෙන් ඔලු තියාගන්න. හරි. මොකද මම අහනකොට ආයෙත් කියා දෙන්න බෑ. මම ආයෙත් grade 11 යන්න බෑනේ. Okay. Write down that thing. Write on write down the paragraph. The following figures represent how to determine unknown sides of a triangle. Unknown sides of a triangle using trigonometric ratios. Okay. Tanggal keterangan putih. Okay, putih. Now you can do the question number 2, but it is as a homework. Okay, there is your homework. But I need the note of all of you. I need. I want to check that one. The second thing is I need that homework. හරිද? ඒ දෙකම දාන්න ඕනේ. දෙගොල්ලන්ගේ note එකයි homework එක දෙකම දාන්න. කරලා ඉවරලා මට බලන්න. හරි. Okay. Now tell me, what's about today's lesson? Do you have any clarifications to be done? Or are you clear with all? Homework is question number 2, Putih. Question number 2. Question number 2 in the tube. Question number 2 in the tube. But actually, I skip that question because you have to find some values, no? Lazy at me. Question number 2. Sorry, question number 2. Not gonna. මම ඒගොල්ලෝ තව මේකක්. Putih, I have sent you 3 figures. So I have sent you 3 figures. 1, 2, and 3. Question okay, let's do the question number 2 first. Meanwhile, I will write the question for these 3 figures and send that to you. Okay, then you have to do that also. Question number 2 and the questions that I will send that to you. Okay. question I will send that to you. Other questions I will send that to you. And okay. Tomorrow our class will be started at 5:30 a.m. So our lesson will be a dynamic lesson. That means linear motion. Linear motion. We will start to learn about graph putting. මේක හරියටම ඉගෙන ගන්න ඕන කාරණයක්. ගොඩාක් වෙලාවට ඒක නිකන් ඔහේ අත ගන්නවා විතරයි. මොකද ඒක ලොකුට question එක නැති නිසා. ඒවට ඒක නෙමෙයි මෙතන වැදගත්කම. ඔය graph කියන එක පුතේ අපිට හැමතැනම එදෙනවා මේ physics වල. අපිට VT curve එකකින් ඊට පස්සේ ST curve එකකින් අපිට question ඉන්නේ නැහැ. එන්න පුළුවන් බොහොම පොඩ්ඩයි. හරිද? හැබැයි graph කියන එක ගත්තොත් ඔයාලා බලන්න ඒවල පේපර් එකක් බලන්න graph කීයක් අපිට තියෙනවා. අපිට තියෙන graph පුතේ සාමාන්‍ය question paper එකක් ගත්තොත් graph questions 10කට වඩා තියෙනවා. සාමාන්‍ය normal 10 questions වගේ තියෙනවා. ඒ නිසා අපි ඔය graph කියන දේ අපි හරියට මේ understand කරගත්තේ නැත්නම් එහෙම අපිට මෙතන උගලක් කරගන්න බෑ. හරිද? නිකම් බොරුවට මේ අර කිසිම දෙයක් කරගන්න බැරි වෙනවා ඒ graph questions වල. හරිද? ඒ නිසා අනිවාර්යෙන් graph කියන දේ ඔළුවට ගන්න ඕනි. Not about PT graph, not about SG graph. You have to learn about graph first. Okay? And then you can do anything. Right? Therefore, tomorrow we'll start linear motions. That is about graph today. So we will learn about ST curves and VT curves. So tomorrow our lesson will be that we will start from 5:30 a.m. Hi, make a recording එක තව සාමාන්‍ය මම හිතන්නේ within half an hour available වෙයි. I will share the recording so you can watch that too. Okay, then everyone, I think sorry, AM tomorrow AM 5:30 AM හොඳේ 5:30 AM to 10:30 AM හොඳේ 5 hours. 5:30 AM. Okay, Mute. So we can complete today's class. If you have any questions, please let me know. If you have any questions, please let me know. Then we can meet tomorrow. Okay. So have a nice day.
Thank you, sir. Bye, sir.
Welcome.